Okay, we're going to use logs to solve exponential unknowns. And what we mean by that is like a variable that's in the exponent. So we have two bases. They're not quite the same. We could technically find the similar bases and kind of put coefficients in front of these things, whatever they are, and then kind of wipe out the base. But we can use logs or log base 10 to do it also. Now the first thing is we don't find the logs of negative valued numbers. But there's a way around this, okay? Think of this like it's the negative 8 to the power of 1 minus 2x. Well, if I move this all to the other side, it can now kind of be written like this, 8, 2x, okay? So positive 8. And then what that means is I can then also move the 32 to the other side. It becomes positive 32, 1 minus x. Or another way to think of this, like we divide by negative 1 or we multiply by negative 1. But either way, we're kind of eliminating these negative values here, okay? So let's kind of start with the first thing we had. We flip sides, okay? So I'm going to rewrite 32, 1 minus x over here, and 8 to the power of 1 minus 2x over here. Now, technically, it doesn't make a difference which side we wrote it on, but I just wanted to show you that. Now, what we're going to do is we're going to take the log, and they call it log base 10, of both sides. So what does that mean? Well, I'm going to say log. And they say base 10 because you usually write like a subscript 10 in here, but it's actually assumed 10 is always going to be there. And that's not really important for what we need to do. So we're going to say log of 32 to the power of 1 minus x is equal to the log of 8 to the power of 1 minus 2x, okay? And when you take the log of something, the exponent, okay, so both of these exponents can now actually come down and they become coefficients. So we can drop them in front of the log. So I've made this many more steps than it really needed to be. Think of it like this. I now have 1 minus x times log 32 is equal to 1 minus 2x times log 8. So this is what we've really done. Imagine there's no negatives here. I took the log of this and I just brought this to the front. You can technically have done that all in one step. I just kind of showed you all the rules in between. So now that we have that, the idea is to get these guys by themselves. So I want to move this log over. So I'm going to divide both sides by log 32. Divide by log 32. Divide by log 32. Okay. These two are going to cancel. It's like dividing, okay? And log, kind of think of it like it's sine or cos. It stands for like an expression of something. So we now have 1 minus x on the one side is equal to, and here we have 1 minus 2x, and technically it's all above log 32. But the easiest way to isolate for this is just imagine we're going to divide both sides by this value also. So in other words, I'm going to 1 minus 2x. I'm going to divide this entire side by that and do the exact same thing over here. These guys, again, cancel out. So the fastest way of showing you that again, I've shown you every single intermediate step, but I'm going to talk about kind of the shortcut to all this. We have this, and we have log 8 over log 32 here. Actually would have been, if we actually don't do that division, it's going to be way faster. I've complicated the question. But a quick way to have done that is kind of think of like cross multiplying. We could have moved everything around. So log 8 divide log 32. Your calculator will calculate this for you. It'll give you an actual value. So we say log 8 divided by log 32. And it gives us 0.6. Is that what you got?
0.6, yeah.
0.6. Now, I divided, but I actually shouldn't have done that. I should have left that on the other side. So in other words, I'm going to kind of move it back. So think of it like this, 1 minus 2x. And we have 1 minus x. The reason being is because log base 10, 8, and log base 10, 32 is equal to 0.6, and that's like a coefficient. So I can kind of just use that as the coefficient now. And now we're working in logs. 0.6 times that would be 1.2x. We get our x's together, and we get our 1 values together here. So if I bring x to the other side and this to this side, that becomes 1 minus 0.6. This becomes negative 1.2x plus x. think of it like it's a 1. So now we have negative 0.2x. This becomes 0.4. We divide both sides by negative 0.2. As I look at this, it ends up being a much more complex way I discovered than the original way you had it. But on simpler questions, it's actually logs is the fastest way to do it. When you divide those two, you're going to get negative 2 is equal to the value of x. Okay, that cancels out, and that becomes negative 2. Again, normally on simpler exponential questions where it's not like an expression up there, log is the fastest way to really isolate stuff.
Like which one?
Like the very first one you're looking at there.